Alright, I'm going to walk through the steps and showing the bonds between for the molecule C2H6. Alright, so our first step is we're going to count all our valence electrons. So carbon, it has 4 because it's in group 4. And there's 2 in this molecule, so 4 times 2 equals 8. And then hydrogen is in group 1. It has 1 valence electron. And there's 6 in this molecule. So we multiply 1 times 6 and get 6 electrons. And so we're going to add those valence electrons up and end up with 14 total valence electrons. And that's the valence electrons that we have to work with here. All right, and so determining our central atom, typically you're going to have an atom with only 1 in the formula. Or in this case, we've got one with only 2, so whichever one's got the least usually. Also, it's never going to be hydrogen. Hydrogen only has 1 spot for a shared bond, and so it can't really be in the middle. So we're going to draw our carbons, and we'll draw our hydrogens bonding to those. So remember, each line represents 2 shared electrons. And so we can count those up: 2, 4, 6, 8, 10, 12, 14. So that actually uses all of our 14 valence electrons, and so now we are done. Hope this helps. Thanks. All right, today we're going to look at bonding C2H4, which is a covalent bond because hydrogen and carbon are both non-metals. So first step, we need to find out how many valence electrons we have total in this bond. And so carbon has 4, and there are 2 carbon atoms in this compound. So that gives us 8 valence electrons. Hydrogen has 1 because it's in group 1. And there's 4 hydrogen atoms in this compound. So that gives us 4 valence electrons for hydrogen. And so that gives us a total of 12 valence electrons. All right. And now we can go ahead and draw our basics. See if we need to change anything. So typically our central atom is going to be the one with the least. So we're going to put carbon in the middle here. Also, your central atom is never going to be hydrogen because hydrogen can only accept 1 shared bond. And so we can draw our hydrogen bonding to carbon. And you can put these down here or out to the side. That part's not quite as important. All right, and so now we're going to count out how many valence electrons we're already using. So we've got 2, 4, 6, 8, 10. So remember, each line counts as 2 shared electrons. 2, 4, 6, 8, 10. So we're going to subtract 10. And so we've got 2 more valence electrons. And so notice, we can put those here, or we can put those here. We can put 1 on each. But either way, we're going to have a carbon that's happy. It's got 2, 4, 6, 8 valence electrons, and we've got one that's not. It only has 2, 4, 6. What we can do is we can turn these 2 electrons into shared electrons by drawing another line and taking those away. Now if we check our work, we got 2, 4, 6, 8 on this carbon, 2, 4, 6, 8 on this carbon. And notice each hydrogen is already happy because they're already got their 2 shared electrons, so they've got a full shell too. Hope this helped. Thanks for watching. All right, in this video, we're going to draw the bonding structure for NH3, or ammonia. So first step is count our electrons, or valence electrons. So nitrogen is right here in group 5, so it's going to have 5 valence electrons. And there's only 1 in this molecule. So there's just 5 valence electrons from nitrogen. Hydrogen is in group 1, and there's 3 in this molecule, so it's going to give us a total of 8 valence electrons that we have to work with. All right, and we're going to go ahead and draw our bond. So there's only 1 nitrogen, so nitrogen is going to be our central atom. And so we draw a single line connecting each of the atoms. Remember, each line represents 2 valence electrons. So we've got 2, 4, 6. So that takes care of 6 of our valence electrons. We're left over with 2. Notice you're not going to give 2 to any of the hydrogen. They're already happy because they've got 2 shared electrons, which gives them a full outer shell, because hydrogen is in period 1 and it only has 1 electron shell, and it's filled with 2. Right, and so we're going to put our lone electron pair right here. So now we've got 2, 4, 6, 8. We've got all 8 of our valence electrons taken care of, and that is our bond. Hope this helped. Thanks. Hey everybody. Today we're going to show you how to draw the molecular compound N2O. Right, so it's covalent. We know that because nitrogen is a nonmetal and oxygen is a nonmetal. Right, first step is find out how many valence electrons we have to work with. So nitrogen is in group 5, and so it has 5 valence electrons. There's 2 in this molecule, so we multiply it by 2. So we have 10 valence electrons from nitrogen. Oxygen is in group 6, and so we put 6 valence electrons. There's only 1, and so that's going to give us 16 total valence electrons to work with when we're building this bond. Right, so oxygen there's only 1 of, so we're going to make that our central atom. We're going to draw a single bond to start with, connecting each of our atoms. Remember, each bond represents 2 shared electrons, 2, 4. And so we've got 12 more valence electrons that we need to put somewhere. All right, not particularly important where you put these. We're going to put 6 on the top and 6 on the bottom. You'll notice that right now oxygen would be happy. It's got 2, 4, 6, 8 valence electrons, but each nitrogen only has 2, 4, 6. So we've got space for 2 more valence electrons for each of those. But this is all the valence electrons we have. So what we have to do is we have to share some. And so we can take away 2 of these from our oxygen and turn that into a shared pair of electrons, which we represent as a line, right? And that is going to make our nitrogen happy. So notice that we took away 2, we turned it into a line. So that's just turning it from oxygen only to shared valence electrons. We can do the same thing with this other side. And draw another line and take away those 2. So now those 2 electrons count for oxygen, but they also count for nitrogen. So nitrogen has 2, 4, 6, 8, and oxygen has 2, 4, 6, 8, and this nitrogen has 2, 4, 6, 8 valence electrons. So we are done. Hope that helped. Thanks for watching.